Hello everyone, myself N. Arun Kumar from SS College of Technology in the Department of ECE. In this video, we are going to see about DT-based steady-state error controls. So first stage is empathy. So in this stage, we can define the processing of how to declare the variables for control systems. There are some problem statements which are present in this slide, uh, especially for control system. So these are all some basics idea we need to include for this empathy. First one is if the output of the control system at a steady state does not exactly match with the input, the system is said to have a steady state errors. The physical control system inherently suffers steady state errors in response to certain type of inputs. Sometimes it may be occur because of acceleration problems or velocity problems or temperature issues. A system may have no steady state error to step input, but the same system may exhibit a non-zero steady-state error at a ramp input. Control system may be classified according to their ability to follow step input, ramp input, and parabolic inputs. So only these three things are included for control signals. These are the signals which produce an error so that we can include in this empathy stage. The magnitude of the steady state errors due to these individual inputs are indicate of the goodies of the systems. Next one is consider define process. While define, we can able to get the information based on the steady state errors. So in this unity feedback control system with the following open loop transfer functions, especially for S power n. So based on the n only, we can able to predefine the system variables. For example, n equal to 0, it is a type 0 system, n equal to 1, type 1 system, n equal to 2, type 2 systems. So only there are three systems are there based on the n value. If it is having more number of n equal to 3 or 4, then it can be considered as a type 2 systems. It is all comes under parabolic conditions. The static error constants are the figures of merit of the control systems. The higher the constants, the smaller the steady state errors. It is based on position, velocity, pressure, temperature. Therefore, it that follows we shall call out the output position, the rate of change of output with velocity, and so on. This means that the temperature control system position represents the output temperature, velocity represents the rate of change of output with respect to temperature, and so on. So these are also main concepts which will create an error in the control systems. So already we have discussed about these three systems: type 0, type 1, type 2. There are three inputs: step input, ramp input, and acceleration input. So based on the input, the types are generated. Initially, the type 0 system is generated as a step input, and type 1 system has generated in ramp input, and type 2 system has generated in acceleration input. So none other than all the other terminals are 0 or input based on the input values given to the corresponding equations. Ideate process. So normally the transfer functions are having input signals, output signals, transfer function, and summer. Then in between input and control system transfer function, the error has been generated. So these errors has to identify based on the type 0, type 1, type 2 systems. It is based on positional error, velocity error, and acceleration errors. These errors has to be rectified with the help of PD controllers. After that, we can pass to the next level so that we can get the concern errors in the proper manner. So once the errors are generated, you can able to calculate based on the transfer equations. Especially for closed loop transfer function, it is a default equation derived by g of s divided by 1 plus g of s. If it is having any feedback loop is if it is having any loop arrived in the feedback loop, then automatically the feedback loop has to be merged with the control system transfer functions. The errors are calculated by using this transfer functions. Error statement with respect to input divided by 1 plus z of s. So error of the system is 1 plus z of s into r of s. Then we can eliminate the errors by giving a limitation to the systems. Limit s tends to 0, s into e of s. Automatically the value will be given to the corresponding transfer equation so that we can eliminate the errors by cross-relating, correlating with each other. Then we can get the final equation as z of s equal to z of s 0. It can be varied based on the positional velocity and accelerations problems. Prototyping, after initiating the ideate process, we can conclude the next prototyping level. We can add or eliminate the errors based on the position, velocity and acceleration process by applying a limit to the concerned equations. So after applying the concerned equation to the concerned columns, just errors are eliminated based on the transfer function of the systems. So these are all some additional block diagram added to the control systems. Testing, after finalizing the prototyping model, we need to test the process by checking the output with respect to the input signals. So the errors may be generated with respect to input to the output signals. So this time these error signals has to be identified by using the testing process, and we can test the type 0, type 1, type 2 systems. Based on the types, we can able to send the information to the next level. So these are all some testing process which has to be followed as type 0, type 1, type 2 system. So the same process, the type 0 system is steady state error formula is given. If it is any error constants, that has to be checked with the three type of inputs. Then automatically we have to check the errors. Initially the errors type 0 systems are introduced as a step input. And second is type 1 system has been generated in the ramp input, and type 2 input errors are generated in the parabolic inputs. So like that all the levels are checked with the help of type of these systems. So here they are given about one control system function with respect to input signals. In this, since this we have to identify which type of system is there. Since there are SEs there, S is S power 1, so the system is set to as a type 1 system. And we need to check the steady state error for step input, and there will be a infinite error for the parabolic input. The only input that will yield a finite steady state error in the system is a ramp input. To choose a case such that the closed loop system has a steady state error of 0.1 in response to the ramp reference. After finalizing, after calculating all the values, we get the value of steady state error point is 0.1 with respect to the ramp reference. Then we can able to find the graph of the concerned equations based on the gain of k value equal to 1. Thank you.